put parentheses around the fractions, but if I think it helps just to make sure you don't mess it up. I'm not going to put the division by 1 because it's not necessary. And then the 4, 5, or 3, use the pi key. And there you go. Now on the other one, same idea. I'm going to go and set it up. It's 1/2 r squared, which is 1.5 squared. Once again, I'd make that like the numerator. And you can't use the 102. You have to convert it. I'm just going to put the conversion right there. You multiply by, will you tell me, pi over 180 or 180 over pi? Yeah. And so you can do this separate, and then once you get to radians, plug it in the formula, or just put it right there. So this ends up being your radians. And then you just type it in again. Yes? That's what we're saying. In fact, look in the board. Once again, the arcing formula and the area formula. Yes, it has to be in radians for that to work. And actually, if you go back to geometry, you had different formulas there. And in those, they had to be in degrees. Had to be. If you used radians, it'd be wrong there. It wouldn't work. And seriously, if you put... Here, watch this. 1 radian is around... It's almost 60 degrees. It's around 57 degrees. Which means if you use the 102, your answer is about 57 times bigger than it should be. So make sure you use radians. All right. And you should get around 2 on that one if you type that in. And frankly, if you have trouble, if you have questions about how to type it in, when we're done with this, I'll show you, okay? Let's do one of these. And really, the bottom 2 are easier because they're in radians. One thing I want you to realize is, like here, they gave you the area of the sector, right? Well, if they gave you the answer to the formula, then you should realize you're going to need to use that formula. And so I'll go ahead and set it up. Since they gave you the area, put that there. And just set up your formula. R squared, well, we're trying to find R. And then the angle goes here. Once again, though, the angle has to be in radians. So either convert the 68 degrees to radians separately, or just put the conversion in there. And it's a calculator problem, so get it set up like that. And then just type all this in. I mean, the 1/2, all the numbers there except for the R squared. Tell me what you get. You get 0.59 something? Well, then that's just 0.59 times R squared. 2 easy steps to finish it. Divide by 0.59, right? But look, on your calculator, what I want you to do is type in, you were trying to do 29 divided by the last answer. So do 29 divided by second answer. Once again, you want to avoid rounding errors. And you get around 48.9, right? And then last step you do what? And if you take square root of that, you get something close to 7. I'm just going to set up the next one. And I'll let you, if you didn't finish it, I'll let you try tonight, and I'll go over the rest of them tomorrow. But this one, do the same thing. Put the area there. The formula is 1/2 R squared, so put the 1/2, put the R squared, and then theta is already in radians, so you just put the angle there. And then do the same thing. Type this in, get a decimal, and then you divide, and then you take square root. and you have the radius. Let's do one of these. Yep, we'll do the first one. What did they give you? What is the 9? Right, arc length. And by what letter do we use for arc length? S. So once again, they basically gave you the answer to a formula, so we should realize that. Realize you're going to use this formula. This is actually really easy. You just set it up. Here's your formula. So the 9 goes there on the left side. The radius is given. Theta is what you're trying to find. What units is theta in? Radians. If you divide by 5, then you're done. The answer is 9/5 radians. Which sounds kind of weird because everything before was like, 3 pi radians, 3 pi over 4 radians. It was in terms of pi. But it doesn't have to be. Look, this is the answer, but watch this. That is like 1 4/5, which is like 1.8 radians. And we like the answer like this, but I want you to see how big this is. So here, watch this. If I want to graph 1.8 radians, can you tell me which quadrant it would be in? Now, first of all, pi radians is here. This is less than 3.4, right? So it's either first or second. Pi over 2 is what is a decimal? This is 3.4. This is half of 1.57. Well, that means 1.8 radians is the second quadrant, doesn't it? And so, like I said before, radians, they like it, to express them exactly in terms of pi, but sometimes you need to think about them as being decimal form, okay? So, that's our answer in radians. It said also convert to degrees. So, let me write it again. This is the same answer, but I'm going to convert it to degrees. And what do I multiply by? Pi over 180, or 180 over pi. Good. Because once again, you want to end up with degrees in your answer, right? And it didn't say whether to give the exact answer or just round. So I'm going to do both. First of all, if you cancel, that gives them 36 times. And then what do you get when you multiply 9 times 36? And so it looks weird, different, but you get 324 over pi degrees. Then go and type that in the calculator to get your decimal answer. Just round to the nearest tenth. What? 1. Okay. And so once again, that, if it didn't specify, give me whichever answer you want, the exact or the decimal. All right. One more. And then you get to these. This one actually is easy. You can just put those two together. They have the same radius. Put the angles together and just treat it like one sector. Okay? Unlike this one. The problem is, we don't have a formula for this. If we did a formula, we'd have a formula for that whole sector, right? And you can't just put the two together because they have different angles. So you really have to figure out the area of this, find the area of that, and then add the two. Do the easy one first. Figure out the area of this little sector first. So it's 1/2. What's the radius? So 8 squared times the angle, except it can't be in degrees. So once again, just put the conversion right there. Type it all in real quick. And I'm going to show you how we're going to have to do that same formula like 3 times in a row. I'm going to show you how you can avoid having to type it in repeatedly. Bless you. And the 8 squared is over 1. I'm not going to put the over 1. The 88 is over 1. I'm not going to put that either. Did you get that? 49 point something? All right, let me get that on paper. Now, let's store that. We're going to need to like add and stack these later. So just store that. We'll store next. Store buttons right there. Press X. We'll get that back later. Now for this, what we're going to do is find the area of the whole big sector and then subtract away that little part we don't want. Okay. So let me set it up for the whole thing. The catch is, what is the radius for that sector? Yeah, and not 12. 12 is only that much. So yeah, you're right. It's 20. So be careful there. So same formula. It's 20 squared for the radius squared. The angle is the 104, which once you convert to radians. So write that down. And what changed from the last problem? Well, I guess two parts of it, right? So here, watch this. On your calculator, do second enter, and then do second enter again, and you can bring up where we typed in before. Then you just go over and edit it. And this thing's painfully slow. Hopefully yours are faster. All right. And the 88 degrees changes to 104. No, I'm sorry. No, the 8 centimeters changes to 20. Watch. If I type over, I need to enter another digit. Do second delete. Put you in insert mode. Then come over here. And on the angle, the same is going to happen. I'm trying to type in 104 now. Well, I need to change the insert mode. So I can type in the 4. On that one, it might have been faster just to retype it. So the good news is we're almost done. That is not our answer, though, because once again, that includes the part we don't want. So now we need to find the area of that part. What's the radius now? The nice thing is that now that's the only thing that changes. The angle's still 104. So now second enter will really be helpful. Change the 20 to an 8. Let's say 08. Okay, I need someone to explain what we do with these three numbers to finish this up. One person, raise your hand. Isn't that the way it works? Yeah. All right, Barsham. All right, pause. Let us do that. Okay, yeah, you're right. And I forgot to store the 363. It's not a big deal. But you do want to avoid running errors, so you're going to have to type it in. Type in more decimal places than you want in your final answer. And I had the 58 there, so I will do second answer for that. And so yeah, this area turns out to be 304.94. I stored the first area in X, so I'm just going to do plus X. And you should have that, which they apparently run, and then there's poles per centimeter. I would have preferred 0.1, nearest tenth. All right, so listen. Tonight, finish this up. Do the ones that we hadn't already covered. Right now, what I want you to do is work on the application problems you just picked up. And if you have questions about them, ask, but I'm not going to go over them initially.